Hi, everybody. Welcome to Properties of Matter and how do we tell different types of matter apart. So our first idea is that there are differing properties. What exactly is a property? It is defined as an attribute or physical quality of the matter. Sometimes it's how it looks. Sometimes it's how it tastes, like salt versus sugar. What exactly do we have that is different about them? And you might say, well, one tastes sweet and the other one tastes salty. Exactly. Those are the properties we are referring to. So there are going to be two types of properties that we pay close attention to. Those that I was just describing, called physical properties, and then those that are called chemical properties. Let's go ahead and take a look first at physical properties. These are going to be properties that you can observe without changing the identity of the material. For example, the rubber band can be stretched. It is still a rubber band. You can let it pop back. It is still a rubber band. Physical properties oftentimes are descriptive. So we would describe its appearance. We would describe its behavior. I was just describing the behavior of the rubber band. Appearance is how it looks, tastes, smells, as well as any measurable characteristics like mass or volume. And then the behavior of an item is going to be how it reacts with other things. For instance, how are they attracted to magnets? What is their density? Are they able to have a certain color? Does their color change? All of those things are their behavior. So what are some properties of this honey? Well, let's give it some thought. I see, in fact, that it looks very sticky. It is actually hanging on to that honeycomb that's there. It also is sweet. I know that because I've tasted honey before, and it appears to have that yellowish look to it. So those are some physical properties of honey. So when we describe physical properties, we also have to be able to talk about their physical changes. In other words, when we talk about a physical change, we mean a change in size, shape, or phase. And by phase, we mean phase of matter, as in solid or liquid or gas. Okay, we are not changing the identity of the subject. It can be changed back by changing temperature, for instance, in the state of matter. Another way to look at it is yes, we can change it back. Common physical changes, in addition to states of matter, are size, shape, and how well it dissolves or how much can be dissolved. So these are all things that can be changed back. Dissolving is one of those things, though, that makes everybody just a little confused, because if I dissolve the salt, it seems to disappear. However, it is just in the water. If you were to taste the water after I dissolve it, you know that the water now tastes salty. So the salt is retaining its physical property of that salty taste. How could I get the salt back? If we said that the makeup of it does not change, well, how do I get it back? And in the case of salt water, or dissolving, we can evaporate the water until all I have left is a crusty solid residue, which is my salt. So I've been able to get it back. So in the case of dissolving is always just a physical change. Well, how about chemical properties? These are going to be characteristics that describe how a chemical change is happening to your matter that you have. How well does it light on fire? That is flammability. How well does it react? Reactivity. Does it rust? In other words, does it undergo oxidation? So you can see by the way this looks that this railroad spike actually has undergone rusting or oxidation. So that is one of its chemical properties based on how it's made or what it's made of. Chemical changes. In other words, we're chemically going to be changing substances from one into another. We are going to be breaking chemical bonds, and we might be making new chemical bonds. These are going to be things that you can't change back unless it undergoes another chemical change. So a new substance will be formed as a result of a chemical change. So chemical changes, in this example, new substances are produced, and this is supposed to be an animation. Let's see if we can make that animation go It does not look it. So let me see if I can describe the animation for you. What would have happened here is you would have seen the little blue and yellow dots separate from each other, and maybe two yellow dots would get together, or you would have seen the blue and the bigger yellow dot get together. So that was what this animation was supposed to show you here. Okay, indicators of chemical change. So these are all going to be evidence that we might observe of a chemical change. And oftentimes that question is asked of you just like that. What evidence of a chemical change can you observe? So there might be an unexpected color change. Notice that my penny in this picture is changing from a copper brownish color to now it's looking like it has some green on it, much like the Statue of Liberty is green. You might experience an energy transfer. By that I mean you might be able to discern that there has been a temperature change. Things might have gotten hotter, they might have gotten colder. We might have a precipitate that is produced, and we're going to define a precipitate as a solid that is produced without freezing or without solidification. So a solid is produced as a result of a chemical reaction. You might have an odor or a gas produced. Odors imply that there has been a gas produced. Odors, of course, are smells. What if a gas does not have a smell? It might result in bubbling or fizzing or an expansion of something, say, like a balloon. So an unexpected color change. All of these are good examples. We might have our iron key there change from a dark gray to now an orangish sort of dirty color. We might have our egg change from a clear and yellow center to a white and yellow center. We might have our fork change from a silver fork to now an oxidized black looking fork that's got some silver oxide on the outside. That particular color change is a chemical reaction. It's called tarnishing. And then we might have our penny, which is made of copper, begin to oxidize and turn into our, much like our Statue of Liberty, having a green patina on the outside. Now, what about these two clear liquids, which when you mix them forms a yellow solid? You're starting to see the yellow. Why did I say it was a solid? Because it is forming a more dense set of particles that are sinking to the bottom of that test tube, and it very definitely is an unexpected color change. You might wonder, what is not an unexpected color change? Here's an example. If I get some Kool-Aid powder and I'm mixing my Kool-Aid juice, and the powder is for red Kool-Aid or cherry flavored Kool-Aid, I will end up with red colored Kool-Aid. That is not an unexpected color change. That color change is completely expected. Just like if I put blue food coloring into water, I'm going to expect that my water changes to a blue color. That is an expected color change. All right, what about energy transfer? We have two terms for energy transfer. One where we experience cold, so endothermic, in other words, heat is being absorbed. And another where we have exothermic, in other words, it feels hot to us and heat is being released. In energy transfer, it might result in an explosion, and that would include light and sound as well as heat being produced. So you might have a very large amount of energy that is transferred in that case. What about this thing about a precipitate forming? When we have two clear liquids like liquid A and liquid B there, and we mix them, it is very possible that we will end up with a result that is actually a mixture of a clear liquid but a yellow solid that ultimately falls to the bottom of the solution. It is that precipitate that falls to the bottom of the solution that is what we are defining when we say a precipitate is produced. This is a solid that is produced without freezing. So that's why do we call it a precipitate in chemistry? That precipitation is rain, isn't it? Well, think about this. In our atmosphere, rain falls to the earth due to gravity. In our test tube, The solid falls to the bottom of the test tube due to gravity overcoming buoyant force, or more dense things sink in less dense liquids. We have learned about that already. We could also have evidence of a gas being produced when we smell bad things. We might smell rotting pumpkins, or we might smell our milk has gone bad, or we might smell a bunch of garbage, or we might have a good smell like the smell of cookies baking in the oven. So an odor produced is evidence of a chemical change. We also might have other evidence of chemical change where we can see a gas that is produced. So a chemical change happens when you drop your Alka-Seltzer into water and it begins to bubble. You might have a chemical change occurring like in that bottle and you're collecting the gas in the balloon. And you might have the bubbles that are trapped inside the liquid, Coca-Cola, that start to come out when you release the pressure. Gas produced, fizzing, bubbling. And that is the end of our presentation.